Chapter 9, Day 1. Again, don't worry about it till after the test, but we'll have some notes on it. Testing a claim. And I have to say that I think the book has done a really good job leading us up to this. So I don't think this is going to be like some scary thing. But it is a really big idea in stats. It's one of the main, getting inference, like we did in the last chapter, and testing a claim are a couple, I think, of the biggest ideas for this semester. But guess what? It's just standardizing. So we call this significance testing. And we've already talked about significance. What have I said about things being significant? If it's in the tail, right? It's unlikely to occur and it's significant. We've talked about that in the past. Okay, so we're looking to see if an event is likely to or not to happen. Sometimes we deal with one tail, sometimes we deal with two tails. Just kind of depends on the context. So we've dealt with confidence intervals. It's very similar to that. Anything inside here is likely. I should probably put a frowny face here because my example is going to be winning the lottery. So it's actually likely that I'm not going to win the lottery, right? And then maybe that's a happy thing. I don't know. I've never won, so maybe my niece would bring her dogs and say, I'm going to take over your house unless you give me $1 million. I'd be like, yeah, you just take the house. Unlikely. And it could be happy, it could be sad. I'm putting some saddy faces in there, so it's unlikely that I'm going to win the lottery because it's an unlikely event to happen, right? So these are your significant. Where when you're in a tail, one side or the other, it's significant. It's not likely to happen, so we get to deal with hypotheses now. So we have the null hypothesis. Is what we are testing against. This is the claim. We use the letters HO. I'm thinking Santa must have wrote this part of statistics. Oh, right. That's the null hypothesis. And this is the claim. A great example of the claim is if you go to the store and you buy a bottle of soda, or you go to the vending machine and you buy a bottle of soda. On the bottle it says 20 ounces of soda is in the bottle. Okay, that's the claim. So we would say the HO, the null hypothesis, is 20 ounces. Another way to think of the claim, that's the mu, the population mean. So the company is claiming that their bottles have 20 ounces. Well, maybe I'm a concerned consumer, and so I take and I measure the amount of liquid in every soda bottle I buy. Let's say I only buy Coca-Cola. I'll pick on the Coke company. I only buy Coca-Cola. And so I find that they're not filling their bottles to 20 ounces. So my alternative hypothesis is our sample data that may contradict the null. We use ha! I reject your claim and I substitute my own reality. Caught you and I'm taking you to court. My samples show the Coke bottles are underfilled or overfilled, whatever. Overfilled is a problem too. It's a problem for the company more so than the consumer. But maybe you have that wacky consumer that goes, I bought a bottle of soda every day for the last 20 years. Now I find out that I've gotten a quarter ounce per bottle more than what was claimed on the side. So I'm getting, I don't know, an extra 10 calories on top of what's stated. And now I'm obese, and so it's the Coca-Cola company's fault. I'm probably stretching it a little bit. Yeah, I'm probably stretching it a bit, just a tad. Okay. So we have one-sided tests and two-sided tests. Is everybody with me on this? You got the null and the alternative. Ho and ha. It's a good thing you stayed in this class. This is when stats starts getting fun. On a one-sided test, we're only concerned about one tail. Either on the high side, too much. In the soda example, the company would be concerned if they're overfilling the bottles. All right, they're losing money. That would be the too much example. In the too little example, well, they're underfilling and they're at risk of being sued for it because they're not supplying the customer with the amount of product that they're promising. All right, that's a problem. They can underfill it by a little bit. You know, there's a margin of error that's allowable by law, but if it's too much below that, it's a problem. So we've got the too much and the too little situation, where these guys are where we're either looking to be or not to be, depending on who's looking, or the two-sided test. And this is there a difference? And that's really the terminology you want to kind of get in your head. Bless you. Keyword there, difference. So this looks like your confidence interval where you have a tail in each end. And so you don't really know, is your situation, if it's a Coke bottle kind of situation, you don't know if it's overfilled or underfilled, but you know that if you're in either of these tails, it's a problem. Does that make sense? So it's out of the ordinary if you're in a tail. Is there a difference? Two-sided test. You don't really know. Okay, so we need to mention a couple of new things. P-value isn't really new. We've been looking at p-value for quite a while now. It's the probability that something occurs. Table A, right? What do we have to do when we're pulling a value off table A? What have we done all along? When in doubt, answer standardize. Right, standardize. Yeah, so really this is just standardizing. But the p-value is the probability that something occurs. If the probability that something occurs is in a tail somewhere, that's a problem. Probably a problem. The next thing is new, alpha. Alpha. And it's this Greek letter that looks like the fish. Okay, call it the fish. Looks like a fish. It is the critical value or I like to think of it as line in the sand. That differentiates between likely and unlikely. So in the examples that I drew with your one tail and your two tails and such, your alpha would be that where the tail starts. That's your alpha. And you get to set that based on the same rules that we talked about before. 90%, 90, 95%, 99%. Those are the ones that we use the most. We'll talk more about that later. But if the p-value is less than or equal to alpha, then we reject the null. We say we have convincing evidence what other class are you going to learn how to reject the hoe? Okay? Really? Would you expect it anywhere else on this campus? Okay? Science? What? Oh, personal finance? Okay, all right. All right, I'll go with that. So if the p-value, I wrote that on the board a couple years ago and my freshman came in and went, what is that? And I said, well, you'll have to take stats to find out. If the p-value is, maybe it was one of you. If the p-value is greater than alpha, then we say we fail to reject the null, the HO. I'm kind of going to cut this short. We have convincing evidence basically against the null, but we fail to reject the null. We don't say that we never say that we accept the null. I'm running out of time here, I know. And that's okay, because we're done with the notes. We never say that we accept the null. Because what if we had a situation where, what if we had a situation where I buy 50 bottles of soda and I measure them and they're underfilled, but they're not quite underfilled enough to a level where I could say, Mr. Coca-Cola, I'm taking you to court and I'm going to sue you for the price of the 50 bottles that you didn't give me enough soda in, right? Or something like that. What if you're not quite there, but clearly you have evidence that there's some underfilling going on, just not enough that the court would say there's a problem? Would you accept their claim if you had that kind of data? No, of course you wouldn't. But you don't have enough, your data doesn't show enough evidence for you to reject their claim. But it's close, right? So that's why you fail to reject the null. You never accept. We never accept the null. Okay. All right. So thank you.